Hello, my name is Raj Chako. I am a consulting systems engineer at Cisco Systems. Today I would like to demonstrate how to install the Nexus 1000V software switch on ESX Hypervisor 5.1, and we're going to be running the software version 4.2.1.sv2.1.1a, which is the latest release as of late January 2013. Right, so I'm going to speed through the process of installing my vCenter server. What I did was I downloaded and installed the appliance, and as you can see, once you are done downloading and installing, you have to do some basic configuration. I know you have done this many times, but I just wanted to show you that this was a clean install. And also the way I've set up my network here in my lab is I have 3 different subnets. One subnet is for my first host. Second subnet is going to be a second host. As you can see, I'm setting up both my hosts here. One was on .51 network and the second host is on .52 network. And my vCenter server is on .55 subnet. Alright, so once you download the software, you can extract it, and you will see it's going to extract into a bunch of folders. Find the folder of installer.app, and the application is a Java applet. It opens up and you have multiple options here. You can install 1000V. I would go with the custom option because standard doesn't allow you to select some of the enhanced options, for example your data store, so I would select custom. You can also come back here to install your additional web modules, or if you want to set up your vCenter connection again. The installer app is pretty straightforward. It's about 6 to 7 steps that you have to go through. So once you specify your vCenter server information and provide the credentials, you will be presented with this window here where you have to provide the information regarding the physical hosts that you want to be installing your virtual supervisor modules. And you can also save the configuration once you save it, so you can at later time import it using your import configuration wizard here. Since the installer app knows the VMware server credentials, you can quickly browse and fill in all the required fields here. So in my case, I'm going to select my primary VSM host and also the secondary VSM host using this wizard here. One thing to keep in mind is that the installer app enforces the fact that you have to have both a primary and a secondary supervisor module. In my case, I also wanted to select a different data store, so this is one of the options that you get when you go through the custom install rather than the standard install. So I'm going to go ahead and select a different data store which has more space for my supervisor modules. Understand that the supervisor module is a fairly large install. It also has some memory requirements. For example, you have to have a minimum of 2 gigs of memory that is required for the supervisor module. The vSwitch selection is pretty simple. You just want to make sure which switch you want your virtual supervisor module to reside in. In my case, there's only one switch, but after the install is complete, we can move our supervisors into the newly installed Nexus 1000V switch outside of vSwitch, and we could completely eliminate the inbuilt vSwitch. I'm going to do the exact same thing with my second host. As you can see, the second host is a completely different IP address, and like I mentioned earlier, these are all going to be sitting on completely different VLANs, and this is going to come in handy as I explain further down on the installation script. How do you manage configuration, especially when it comes to different VLANs, and what your management VLAN should look like. The switch name essentially is the 1000V switch name that you want to provide. This would show up in your vCenter software app. So in my case, I'm going to call it Nexus-VSM, and your admin password, there are some minimum requirements. Once you adhere to those, this would be your NXOS 1000V admin password. The virtual machine name is essentially what you want to name your VSM or virtual supervisor module virtual machines inside vSphere. So I'm going to call it VSM lab or 1 KB. The OVA image location, if you browse back to the installer apps folder that you have extracted, there's a folder called install right above the installer app under VSM. And once you open it up, you will see that there are a couple of different options here. I have the 1010 OVA, which is my physical appliance. I also have the exact same image right underneath where I can select the OVA file. So once I would select my OVA file, and then my next option is what kind of connectivity do I want from between my VSM and VEMS. So there are two options, layer 3 and layer 2. Going forward, Cisco recommends that you go through layer 3. There are a couple of benefits by selecting layer 3. First of all, it's much easier to troubleshoot. Layer 3 connectivity is much straightforward, and also you have an option to keep your supervisor modules and your virtual Ethernet modules on separate data centers. So you could have a remote data center which can be managed by a pair of supervisor modules sitting on your primary data center. So I'm going to select layer 3 here, and with regards to my VSM IP address, I'm going to make sure that this is an IP address that is reachable using this vSwitch that I've defined earlier. So you want to make sure that whatever VLAN or whatever IP address you pick here is reachable through your installer app. So whatever host you are running the installer app from, you want to be able to ping the subnet as well as this new IP address once you assign it to the virtual supervisor module. The domain ID is an identifier that is a numerical identifier which you would use to identify your the opaque data. So the VAM, the VSM would communicate using that domain ID. I'm going to enable telnet so that I can telnet to the supervisor, and then I have these options here with my control management and packet VLANs. Obviously, since it is layer 3, I don't have to worry about my packet group because my packet port group would reside or run on control port group. In reality, the only real IP address that I'm going to be using to communicate between my VEM and my VSM would be my management IP address. So you have an option to select an existing switch if you have already defined the port groups in your vSwitch, or you can let the installer app create these for you. So in my case, I'm going to select create new, and I'm going to make sure that these port groups that I'm going to define and the VLAN IDs that I'm going to define are again accessible to the host. So you want to make sure that you have your VLANs trunked properly, you have the proper native VLAN, because the native VLAN configuration on an upstream switch could create issues if it is not properly defined. So as you can see, I have I'm going to put my control VLAN in a completely separate VLAN, VLAN 53, but my management VLAN, I'm going to make sure that my VSM IP address is in the same VLAN as my management VLAN. So in my case, it's .54, and I'm going to put it on VLAN 54, and that's the exact same VLAN I'm going to use for my management port group. So the management VLAN at the bottom here describes what VLAN is our VSM going to be in. Why this is important is that if you have a host running on native VLAN, or if you have not defined a VLAN for your host, and you want to make sure that your VSM sits on the same VLAN, you are not able to put 0 or as an input here. You have to have a positive number here. What that means is that you want to make sure that your VSMs are running on a non-native VLAN. Otherwise, you won't be able to reach the VSM. So when the installer app tries to SSH into the VSM, the SSH will fail because it can't reach this IP 10.10.54.10. So you want to make sure that it's a non-native VLAN that you have defined. Alright, now what you could do is, like I said, you would import a configuration, but before that you would save it. So I'm going to save this configuration as an XML file. This will allow me to rerun the script and import this information at a later time. At this point, once you hit next, it's going to validate all this information that you've inserted. So once you confirm the information, and hit next, you will see the install process move on to the next step. I'm going to move my windows here a little bit so you can see clearly. As the installer script starts to unpack the OVA and install the virtual supervisor module virtual machine, you will be able to look at it in the task bar or the recent task or activity bar of both the installer app as well as your vSphere client application. Once both the supervisor modules are deployed, the installer script moves on to the next task, during which it will connect to the vCenter server, and then it will build those VLANs that we had defined, so both the control VLAN and the management VLAN. Once these VLANs are both defined, it will power on your supervisor module. It will actually power on the first supervisor module, the primary, and then once the supervisor module is up, at that point it will SSH into that supervisor module to configure the parameters that you had defined in the installer script. The installer app will configure the vCenter server to tie the 3 physical adapters that are defined to the proper port groups that we had defined. Especially important is the management VLAN here, because you want to make sure that this management VLAN .54 in my case is accessible from the host application. One quick thing I will do is I will do a simple ping test to make sure that my installer host can reach this IP address. Once I'm able to do this test and I know that my host is up, I can be sure of the fact that the SSH next step will be able to communicate with the host and configure it, because that's one issue that you might run into if you're not able to SSH, or if your installer script gets stuck in SSH. Try to troubleshoot what is going on with the management VLAN and are you able to reach this virtual machine. Once the installer app is able to SSH into the supervisor module, it will configure an extension, it will register an extension with vCenter and allow for two-way communication between the supervisor module and the vCenter server. Once the installer script has created the new distributed switch, it will power on the second supervisor module and SSH into that supervisor module and configure it as the secondary of the two pair. Since the primary SUP is up, I'm gonna telnet to my supervisor and test a couple of basic commands. I'll make sure that the supervisor is up and running. I'm able to reach it. I can take a look at the modules that are installed. So the username and password is obviously what you entered earlier during the script configuration. One of the basic commands that you want to do is, of course, show version to show exactly what version you're running here. And I'm going to do a show modules to make sure my secondary is enabled here. So I can see module 2 is my HA standby module, and I can run some additional commands. At this point the installation is complete, and now I have an option to install virtual Ethernet modules on my host. But before that, I want to make sure that I take a look at my networking option here and see if my virtual switch is installed. As you can see, inside my data center it has a new folder, and the installer script has now created a new distributed switch called Nexus VSM, which is the name which we gave during the installer script. The new switch comes with a set of port groups. One is called an uplink port group called unused or quarantine uplink, and it also creates another default port group for the virtual Ethernet ports. Alright, so on to the installer again. At this point I can install my virtual Ethernet modules onto my host. I have two options here. One is to install the web and add the module to Nexus 1000V. I don't want to select that option because that will pull my physical NICs onto the new distributed switch. So I'm gonna I want to manually define it, and I want to make sure that I configure the port groups and port profiles properly. I have, I want to specify the names that I want to put in there. So I'm going to install just the virtual Ethernet modules. So in my case, it's able to detect the two hosts, and I'm able to run through the select them and run through the script where it's gonna deploy the virtual Ethernet modules to both of my hosts. Now in the previous screen, if you were to select the second option where you wanted to install both the virtual Ethernet modules and you wanted to import it, you would want to make sure that your VLANs were set correctly for your management. Again, going back to the earlier issue that I described, right? Where you want to make sure that your management VLAN that you define is reachable. If you select this option that I just selected, that's not a big issue. As long as you can reach these hosts, you are able to connect to them and install the virtual Ethernet modules. Now that my virtual Ethernet modules are installed, I'm going to connect to my ESX host using SSH and do some basic commands. For example, I'm going to look at my status of my virtual Ethernet module. What I'm looking for is my VSM agent VMDP up and running. That's one thing that I would do to make sure that my module is up. Second is I'm going to take a look at the information or the connectivity information between my virtual Ethernet module and my vCenter. So the command for that is vmcmd show card info, or show card, which will show you the card information. And here you want to look for some basic parameters, for example your MAC addresses, your layer 3 mode, what VLANs you are defined for your management and your packet and your control VLANs. But in my case, since I'm doing layer 3, I don't have any information regarding the control and packet VLAN. It's all about management. And I'm going to do the exact same thing on my second host, just to make sure that I have connectivity configured properly on my second virtual Ethernet module. The next step would be to add your host to this new distributed switch that we created. So what you want to do is you want to select the adapters that you want to migrate over, or if you have open adapters, you want to select those to give to the uplink. But one thing you will notice that we don't have an uplink profile that we can really use. We have some default uplink profiles which cannot be really used. So we have to go back to Nexus 1000B and create those port profiles manually. If you had selected the second option during our installer script, this would have been created for you. You would have seen that there would be an uplink port group, and your NICs would have already been migrated over to this uplink port group. But since we don't have that, or we didn't select that, and we chose to do it manually, we will have to go through a few steps. One, we have to create a new uplink port profile. So the command's very simple. You would type in port profile, and you want to select type Ethernet because it's going to be a physical adapter. The other type would be type vEthernet, which is going to be a virtual adapter. But since this is a physical adapter, I'm going to say type Ethernet and give it a name called system uplink. Since it's going to be a trunk port, because I'm going to have multiple VLANs, I'm going to set up as a trunk port. And I'm going to add all my VLANs here that I want to make sure that are communicated through these adapters. And you definitely want to make sure that your native VLAN is configured properly. Again, what you want to look at is that the native VLAN that you select here is the native VLAN that has been defined. In my case, my Ethernet adapters, Ethernet 2 and 3, I selected, or I wanted to make sure beforehand, I chose the default VLAN or VLAN 1 as the native VLAN, which means that all the other VLANs will be tagged, and any untagged frames would be on default VLAN, which is native VLAN 1. So once you double check that and you have configured it properly, you can move on to the rest of the configuration of the uplink port profile. So you definitely want to give it a name that VMware VMware will be able to see. So you type in VMware port group and give it a different name. You can choose not to, and it will show up as system uplink, but in my case I want to call it 1kV uplink. And you would turn the port on, of course, and next we will specify our system VLANs. And the reason why you want to set up the system VLANs is to make sure that the VEM and the VSM can communicate, and the system VLAN allows for those VLANs to be made available even before the VEM or the virtual Ethernet module is programmed by the supervisor module. In this case, to illustrate a point, I'm going to select VLANs 51 and 52 as my system VLANs, because these two are the VLANs that are defined for my two hosts. My supervisor module is sitting on 51 and my secondary is sitting on supervisor 2. Of course, I got an error that I did not have these VLANs defined, so I'm going to manually create those VLANs. So you have to build these VLANs on your 1000V. And you can go back to the port profile by simply typing port profile system uplink and then continue the configuration. At this point, I want to enable it, and when I enable it, you will see that on my 1000V, on my vSphere client, it will show up as being configured. So since I don't remember the command, it's called state space enabled. So state enabled, and I'm gonna minimize my other window here to show you that the vSphere client will see a new port group here. So as soon as I hit enter, you will see a new port group defined. So there it is. So 1kV-uplink is my new port group. So once I have defined this, I'm able to move on and add my physical hosts into the switch and move my NICs to this new uplink. The next step is, of course, if I want to move my existing VM kernel interfaces to this new vSwitch, which I don't want to, so that I'll keep those so I have access to the .51 and .52 networks or the actual host themselves directly in case there's a problem with my vSwitch. And once you hit next, you will see that at the bottom I have these two physical adapters moved in into the new uplink port profile called 1kV uplink. Okay, at this point I'm going to take a look at my hosts and look at my vSphere distributed switch configured. Pay attention to the fact that although those NICs are defined here, the ports defined to the left of those NICs, it seems like they are blocked, and I'm going to talk about it in a second here and why they are blocked. Right, as you can see, there's an X to the left of the adapters there. This goes back to that initial system VLAN that I described earlier. Okay, so next step obviously at this point is I want to make sure that I have port profiles defined for my VEM management. So I'm going to have to create a layer 3 control port on my 1000V that I can use to communicate between my VSM and VEM, my VEM. So what I'm going to do is I'm going to create a vEth port group from my Nexus 1000V switch, and this port group I'm going to call the port profile, I'm going to call it L3-VLAN-51 for my 51 host, and I'm going to create a similar one more for my .52 host. Since this is an access port, I'm going to create it as a access port, and I'll specify the VLAN. At this point, I could rename it to something else using my VMware command, VMware port group command, but I'm going to leave it as is. So you can hit enter there, and this will make sure that this gets defined as a port group. Once you turn it on, you have to enable a capability layer 3 command, but before that I'm going to specify that this is going to be my this is also going to be a system VLAN here, VLAN 51. So VLAN 51 comes up before communication is established between my VSM and my virtual Ethernet module. So the command is capability space L3 control. This allows for me to make sure that this port group will be used for layer 3 control between my VEM and my VSM. So in order to synchronize this to vCenter, I just hit state enabled, type state enabled, and at this point you will see that my new port group L3-VLAN-51 shows up on my vSphere client. I'm going to repeat the same steps for my second host, and I'm going to fast forward this for brevity. Alright, so now I can take a look at my distributed switch, and I can see both my layer 3 VLANs are configured here, 51 and 52. I'm going to add a new adapter, a new VM kernel adapter, because I did not want to migrate my VM kernel from a vSwitch. So at this point, I'm going to pick a different IP address on the same subnet. So essentially, I will have two IP addresses on the same VLAN for my hosts. So I'm going to select for this host, since it's 52, I'm going to select 52, and I give it an IP address, like I said, in that range. So here I'm going to give it 10.10.52. Let's see, 23, or I'm going to pick 12. So once you hit next, you will see that this new VM kernel port is made available, and it's up, and you can quickly do a test, but by pinging it. But what you should have seen by now is, as soon as you create that VM kernel interface, you should have seen the new module enabled. But as you can, like I mentioned earlier, we have these two ports being blocked, and the reason why these are being blocked is because when we configured our system VLANs for those two uplinks, or the uplink port profile, we did not specify VLAN 1 as a system VLAN. As you can clearly see here on the right side, that I should have VLAN 1 selected as default VLAN. Otherwise, this VLAN is not up. There is no communication happening through this VLAN, or the native VLAN here. So all I got to do is go to my Nexus 1000V switch, find out or connect to my configuration of my port profile, the uplink port profile, and make sure that my VLAN 1 is part of my system VLANs. So once I do this, you would see a couple of things happen. One is, of course, the links will come up, and the second is the module will get detected on this hypervisor, or on this host. So I hit refresh to check the status, and obviously the links are up, and there it is. You see that module 3 has come online, and the basic requirement obviously is you want to make sure that you have a proper system uplinks, and you have your layer 3 uplinks configured, or layer 3 port groups configured on your hosts. Pretty straightforward configuration. Now you don't have to do any of this if you let the installer script configure this piece, but I wanted to manually configure it, and it gives me a better understanding of the inner workings of the switch as well. I'll do the exact same thing on my second host, for my second host, which is 51.2. So like I said, I would add a new VM kernel, and obviously you can, the only adapter you can create, or only the port group you can create, is VM kernel, because any other port group should be created from the switch itself, or the 1000V switch. So this one I'm going to give it a 23 address on VLAN 51, and you will notice that as soon as I hit finish, this I will detect a new module on my 1000V supervisor. Module 4 should come up. There it is. At this point, if I do a show module, I can look at my modules that are installed, both my supervisor up and running, and this will conclude the basic presentation of installing Nexus 1000V. Thank you for watching.